Okay, let me try to share my screen. Um, is my screen visible? Is my screen visible?
Yes.
Okay, awesome.
Yes, yes.
Awesome. So I have been reading about admission control for past week, and the first time when I encountered admission control was while I was studying for my exam, like Kubernetes certified, security certified specialist exam, and there I had known about admission controller as something that is used for node restriction, right? So what admission controllers from my point of view can do is it adds extra functionality to the Kubernetes plane, wherein you can basically add your own logic to for any request that is coming from any request that is being coming to the Kubernetes API. You can basically mutate that request using admission control. So a formal definition of admission control is concerned with validating and mutating requests to the Kubernetes API server before they are persisted in HCD. And here they give in this part of the chapter they give few examples of where you can use admission controller. So you can use it to ensuring that new objects cannot be created in namespace that are currently being deleted, or enforcing that new pods are not going to run as root users, making sure that the total sum of memory used by all the pods in a namespace does not exceed a user-friendly, user-defined limit, ensuring that ingress rules cannot be overwritten accidentally, adding a sidecar container to every pod. So these are few of the use cases wherein you can use admission controllers, and this is what we're going to look at in this chapter. So this paragraph basically says that first we'll look at what are admission controllers. We look at a high level diagram which kind of defines what admission controller does. Then we look at how API server consumes these admission controllers. And then there are different ways in which we can implement admission controllers. Like we can use admission controller in different ways. So there are three ways. One is you can use it directly via the API, like writing any program, using any programming language. Second is by using a tool, which is I think controller runtime. And the third one is using gatekeeper, which is also a tool. But we'll see how these three ways are different from each other.
Yeah. Before that, I think anybody think of any other use cases of you have seen in which the controllers, like we have some of them are listed here, and some of you may be already using it somewhere. So anybody has come across any other use case?
I think one place that I have seen personally is also for restricting using any images which are outside some particular registry, like so using images which are to your private registry kind of a use case.
Correct, correct. Yeah, that's so. But there are a lot of I think with Kiverno, which we'll cover I think briefly later. It's there. One of the use case I have seen is kind of putting down some kind of logging and monitoring details. So, for example, let's say there is you put annotation in your pod, or annotations like enable the automation automatic monitoring and what do you call say the observability enable observability for a given pod, right? So when the annotation is being there automatically, uh, that whatever the control running on the system would read that and then try to basically enforce or made those sidecar containers like the way we are seeing for the Istio. Similar one, we can add sidecars for monitoring and logging enablement. So that can be that use case I have seen companies doing that. Yeah. Okay. Go ahead.
Awesome. Um so this let's look at this diagram. This is the basic and like the foundational diagram which explains what admission controller does. Um, so what happens is, assume this as the HTTP request that comes, and our aim is to get it persisted into HCD, right? So what happens? The first thing that happens is the authentication, wherein you ask the question like who is trying to make this particular request, and then there is authorization, which is what resources is that person allowed to use, right? And then there is this. So once these two things are done, right, there is this admission controller next thing that takes place. But what this actually asks is that is that request that the user who is authenticated and authorized, is that request valid in itself or not? Uh, so that is what I understand from admission controller. It basically checks whether what is requested is valid or not. So there is so after authentication and authorization, there is this mutating admission, which basically what you can do is you can add few labels, or you can add or modify. You can mutate the request a little bit, and then there is schema validation, wherein the schema of the request is being checked, and then there is validation admission, which is again a part of admission controller. And then if the request is valid, then you would move to then the request would move to the persisted to HCD. Now few things here. So the mutating admission and the validating admission, these both are part of dynamic admission controllers. And the difference between mutating admission and validating admission is that in mutating admission, as the name suggests, you can mutate the request, you can add certain labels. Whereas in validation admission, there is no mutating, like there is no changing the request. It only validates it. The return value would be only whether the request was valid or not. And in both these cases, there could be the mutating admission and the validating admission. Both these could be a part of your Kubernetes cluster itself, or you could use a webhook. Now, what is a webhook? A webhook is basically, again, this could be like you could use a internal Kubernetes one, or webhook would be something that is external to the cluster. So you have that flexibility wherein you can write your logic outside the cluster, or maybe inside, but you have this option to write it outside the cluster. And then uh, if correct authentication has been provided, then your cluster can access these webhooks and do the checking that is required. So this is the overview of admission controller. Are there any questions around this, or any comments? No, right? So just a small recap. So there is a request that comes in. There is authentication and authorization that is being performed. The next step is mutating admission. So this will change or mutate the request a bit, like adding labels, for example, or adding a sidecar container using Istio, or any such technologies. Then there is schema validation, which will validate the schema. And then there is validation admission, wherein you can write logic to validate the request. And once that is a yes, then it will be persisted to HCD. One thing to note in this entire process is that for a request to be not persisted in HCD, any one of these steps, if they go wrong, the request will not be persisted in HCD. But all these steps must be performed and give a valid output to get persisted in HCD. So that's one thing to note. So this is what is explained here in these paragraphs. So what they have done is, yeah, you're
Maybe
saying something, Naveen.
you can open that link, Rahul, that we're going to list down, I think, all the admission controllers what we have. I put on the chat there. In the chat, you can bring that link on the screen. Yeah. So these are the some of the controllers what are there. So if you come down, yeah. So some of them are, these are listed here, and then while you configure, if you configure your, so you can see that they can type here, right? Validating and mutating, right? So you can see that um, what kind of type they are, right? So we can see that, and if you go at the top a bit, you can see that how we can enable them. So go up a bit further up. There would be API, yeah, here, right? So somewhere the API can, yeah, if you look at that in the beginning, right? No, just to go up, Cube API server, and yeah, this is the command line you can say here, right? So this is how we can enable or disable the admission controllers. So as you start your API server, we can kind of check which particular. So some of them are configured by default, and if you want to disable them, you will disable it kind of with the option of disable admission plugin. Otherwise, they would be enabled by default. So this is how we can enable and disable these controllers as start our API server. Yeah, that's what I would kind of add there.
Got it. Yeah, so let's continue. So they are basically in this paragraph, they give an example wherein what they want to do is that in the mutating admission, what they want to do is they want to add a volume in which they they basically mount the service account token. So you can do that in a mutating admission, and there is yeah, it's just an example. Like you can do that. Like you can add a volume and then attach a service account token to it, or check if that service account field is present or not uh, in the mutating admission control. And then yeah, as we spoke about this, right? The difference between the mutating webhook and the uh, the mutating admission controller and validating admission controller is that the prior schema validation step in they are concerned with validating against operational logic, not a standardized schema. Um, Yeah, these validating controllers differ from mutating controllers in the sense that they are only able to admit or reject the request, not modify the payload. They differ from the prior schema validation step in that they are concerned with validating against operational logic, not standardized schema. So this is where they are talking about validating admission controller, and they have provided an example here in this code snippet, uh, wherein they're checking if the namespace that they're trying to create the new resources is not the one which is terminating. So they don't want to create any new resources in the terminating namespace. So that is the kind of check you can do in validation admission controller, and if something like that happens, then they return an error. So this is the example of validation admission controller. Yeah, this is already something we spoke about. For a request to pass all the objects, sorry, for a request to pass and the object to be persisted into HCD, it must be admitted by all validating admission controllers. But for it to be denied, only one controller needs to reject it, right? So the next part is about entry admission controllers. What entry means is that these admission controllers are provided by default by. Oh, there is a hand raised by Arjun. Yeah, go ahead, Arjun.
Yeah, can you go back to that note? I just had one question here. So the controller, admission controller, is it must from validating, or it can be mutating as well? Can a mutating webhook reject the request?
I think it can like deny a request. I'm not 100% sure, but this is my thought. Like it is possible because um,
What is the question again?
So the request, whether it is always rejected by all the validating webhooks, or like mutating webhooks can also reject a request.
Okay.
So
It
ideally,
says
they,
here like it should be all validating admission controllers. Looks like the next sentence is related to the validating admission controllers only, but it I was a little bit confused about that line. Only one controller means it has to be validation or
where is
mutation.
that line? But what technically mutation can do anything, right? So, for example, um, so basically, see, so mutating webhooks should be able to mutate in any way, correct? So, for example, if I am a kind of a say um, a third party plugin, right? And because of the mutation webhooks, I got a request, correct? And then typically what's going to happen is I would send a patch which need to be eventually applied to the original request, and then it would be just applied as it is, which is sent by the mutating webhook, correct? And then there can be multiple mutating webhooks can be there, so they would kind of, they can go in any order, but they would eventually finish, correct? And then what we saw, there was a schema validation, and then the validating webhook was after that, right? So I believe mutation would not typically reject. They should perform what they have to be doing, and rejection would happen only at the case of validation. That is what my understanding is.
But what
Yeah,
it
yeah. I was
says
just
there
reading.
is slightly different, no? I mean, even I'm
Sorry.
confused now.
Yeah, yeah, I just read it on the official website. It says like a controller can act as both,
Okay.
like a mutating and a validator, and any controller can reject whenever they want in the whole sequence. It seems.
Yeah,
That
I
is.
was also reading about it right now. So it says
Yeah.
that it can reject.
Okay. Great. Great. Okay.
It's a good question.
Yeah. Good question.
Awesome. Um, so I guess we should continue. So I was talking about entry admission controllers. It basically means that these like earlier when Kubernetes was like this book, these paragraphs say something like earlier when Kubernetes was like core Kubernetes was designed, it was kind of everything was 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 a part of the Kubernetes code, right? So all these admission controllers were part of the core Kubernetes code base, and that is described as being entry. Uh, so but then in the next few paragraphs they say that however admission controllers is slowly moving forward to the trend of shifting code out of the API server like the core Kubernetes and moving towards increased pluggability, as we are seeing now that everything is moving towards increased pluggability. And so these mutating web admission controllers and the validating admission controllers, these basically help us to these are basically helping us to using of webhooks, which in turn is helping us into increased pluggability. um, all right, so this is just an example. um, So yeah, so as we saw right in the link that Nipendra provided, it says that a subset of built-in admission controllers is enabled by default. These are intended as a set of sane defaults that should work well for most clusters, and they don't give the link here. So we already got that link, and then let's talk about webhooks, like, right. So webhooks is basically so what this note is saying is that webhooks is critical for it's a very critical path for request going through the Kubernetes API. However, there are few problems that also come with having webhooks. There are two problems that I mentioned here. The first one is the latency that comes because basically you're going outside the tree, which is outside the Kubernetes core code base, and you're trying to achieve some kind of request from there, some validation from there. So there is added latency. And the second one is the scope, the broad potential scope of the functionality. So So you can basically call out third-party systems, but it is a drawback wherein you need to be careful of what you're calling and how the objects inside your cluster are being manipulated. Um, that is about webhooks, and so webhooks are a special type of admission controller, and the reason why webhooks are very powerful is for two reasons. One is that they can be written in any language, and that can expose an HTTPS listener. And the second one is they can they can be run in or out of the cluster. We've spoken about this, like, so they can be something which are running inside the cluster, or it could be some other tool, or any logic which is outside of the cluster. Um, and the third one is that we can make callouts to systems and data stores external to Kubernetes to make policy decisions. This is also similar to the second point. This small note, it basically is saying that if you are using webhooks which are external to the Kubernetes cluster, you need to make those certificates available for them to communicate. So the cluster must trust the application in terms of and the application must also trust the uh, Kubernetes cluster that you're working in to make this uh, webhook work. So the next thing that is important is talking about admission review object. So what it means is basically the Kubernetes cluster um, must understand how what are the webhook that you're trying to configure must understand what is present inside the Kubernetes cluster. Otherwise, it would not work in sync. So there are few fields in which the Kubernetes cluster requires the request and response uh, for the Kubernetes cluster to understand the admission controller. So these are few fields that are required in the JSON payload. That is the API version and the kind, the metadata such as namespace, unique ID, the operation that is attempted, that is if it is create or delete or whatever the operation is, information about the user who's initiating the request, whether this is a dry run request or it is an actual change, and the actual resource that we're trying to do this on. So these are few of the things that must be present in the JSON payload, and then there should be a kind of response that should come out of the webhook, the which the Kubernetes cluster would understand, like the core would understand. That is the unique ID from the request, whether the request should be allowed to proceed, and optim and optional customized error status and message if there is an error. So this is the kind of request and response that is required from the webhook and the Kubernetes cluster, from the Kubernetes API, sorry. And as we've already discussed this point, validating webhooks are not able to modify the request sent to them and can admit or reject only the original object. They cannot modify the request, but can reject or admit the original object. Mm. And in case of mutating webhook, the response structure can also include a patch set if desired. So this is like kind of a patch which you want to apply, like you want to mutate it, right? So this is a patch set, and this would be the change. And a simple example of mutating controller would be to add labels on the labels containing teams or workload specific metadata to power deployment. And another example that they've given is adding a sidecar proxy in many service mesh implementation. So these are just examples. They're going back to the mutating and validating admission controllers. So there is one downside of mutating controllers, which is, as they mentioned, that is basically it removes the visibility of the end user, with objects being applied to the cluster that are not consistent with those that they originally created. So there is this opacity that the end user cannot understand sometimes with the mutating admission controller, is what they're trying to highlight. Are there any questions here or any comments? All right.
Yeah, good. Anybody has written any kind of controller? Anybody a dev here for the Kubernetes? Anybody has run or wrote? We have played a few years ago and have created one business use case. Okay, nice to hear that, Arjun. Okay, so okay, great. Yeah, carry on, Rahul. Sorry.
All right. Awesome. So let's continue now. The next part of this chapter is configuring webhook admission controllers. Um, so this is an example that they have provided us with how a mutating webhook configuration might look. This is like a pseudo config. What it says is it defines the rules for the mutating webhook. It says it needs version v1. It's for creating. So the operation is create. The resource is pods, and the scope is namespace. So this is kind of mutating webhook config, and then so this client config is basically it represents how the webhook is going to communicate with the cluster. So in this case, in the example that they have provided, it's through a service, and this webhook runs on this particular service, and this is the certificate that it requires, and then there is admission review versions, side effects, timeouts, reinvocation policy, and failure policy. So this is how the config looks. So what they're trying to say is that you can actually make your config very granular, and to a point wherein you know that you want to apply this particular mutating webhook only on create, and then pods, and then also namespace. So they're trying to say that you can actually granularize what you want to apply this webhook on. um, and then they've given another example that you can also use resources like secrets, and then you can make that namespaced. And these are just like different examples of the config. They're saying that you can also use a namespace selector in that case, in case of a config. So these are like this is how the config would look like. Okay, so the next part is webhook design considerations. They have provided us with four considerations. One is failure mode, another one is ordering, the third one is performance, and fourth one is the side effects. Uh, Failure modes is basically they're saying that we understand that webhook is like a critical path that in our request structure. So then if anything fails, right, if the request fails, it will not be performed. So then they're saying that if it is unreachable or sends unknown response back to the API server, it is treated as failing. So you need to keep it highly uh, available as well for this not to happen, right? And they're saying for security related webhooks, fail is the safest option, which is recommended. The other one is ordering. Um, so what they're saying is that ordering is very important. Uh, what they mean by that is the mutating webhooks, they must always run before the validating webhooks. It I have not seen a case, but they say something like if after a validating webhook there is a mutating webhook again that runs, then it could violate your policies. So then they want you must pay attention on ordering, that the mutating webhooks run always before the validating webhooks. And one point here is mutating webhooks are not guaranteed to be called in specific order, and may be called multiple times if subsequent hooks modify a request, right? So we need to be careful about that. And there is
So
performance.
Rahul, I
Yeah.
mean, I think it's by default considered that, right? That validation would run after the mutation only, right? Can we change that
Right.
order? I don't see there is any way we can change that.
Right. I was I'm not 100% sure, but because of this ordering, I was forced to like look at some articles, and I got confused about it. This is a question, right? I'm also not 100% sure.
So for
Do you
ordering,
think
I
it
think
is?
no, I think it is. I think ordering can be done only for between the mutating webhooks. There can be an order, but all the validation should always happen after the mutation. So I don't see there is a way by which you can do that because that's how it is designed, I believe.
Right. So you mean that there might be multiple mutating webhooks, and
Yes.
between them there needs to be ordering.
Correct. There can be an ordering
Right.
and validating as it does not change any schema of yours, right? So it is just change checking maybe for different requests whether something is being set or not correctly. So I'm pretty
Perfect.
sure that you can have the ordering between the mutation, uh, but validation should always happen after mutation. That's for sure.
Got it. Got it. Awesome. Thanks. And the next part is performance. So yeah, we spoke about this. Like it should be designed with high availability in mind, but because if you're calling it as a if it is a critical path of your request flowing to the API server, then um, if the request does not go through, like if it is not available, if the webhook or the admission controllers are not available, the request would be denied, and that could be bad. That could be bad. So then it should be designed with high availability in mind. And yeah, there is there's this one comment by the author. He says that as one of our esteemed former colleagues often commented, admission control can become bottleneck as a service if users are not careful in its application. So um, yeah, and then another good point is that whenever writing webhook configurations, you should try to scope them down as tightly as possible to ensure that they're not called unnecessarily or irrelevant or on irrelevant resources. And the last one is side effects. So there is this option called as dry run, but what happens is sometimes I believe this is my understanding that when we call external webhooks, or if we go outside the Kubernetes cluster, then this dry run is sometimes not obeyed or followed. So the author is giving this call and saying that these webhooks should be aware of and respect the dry run option, and skip external state modification when it is enabled. Right. So now that's about the general overview of webhooks, and now there are like, I think there are three ways that they define how you can write a webhook or a mutating webhook. So let's look at those now. So the first way that they define is writing a mutating webhook, and they are using Go programming language for that, and it is a plain HTTPS handler. So one of the advantages of using a webhook model for admission controllers is that we can implement it in any programming language that suits us. So if you look at this snippet, the example that they provided, they're creating a structure, and then they're creating a volume. So their aim is to create a volume in which they mount their service account token, and then add that to the request. So what they're doing is they're creating a structure, and then they're creating a volume in which they're mounting the service account token, and then they're instantiating the structure that they have created over here, and they are giving the path for it, and initiating it and adding the volume to it. And lastly, they are writing you know um, they are uh, they are writing the logic for the volume that they want to mount. And then there is this function called json.marshal, which will basically create the kind of JSON required in the config to provide to the API server. So this is basically an example of the mutating admission controller, and this is the way they want to call this all this code and then provide it to the API server. So this would be the response basically uh, for the mutating admission controller, which would satisfy the condition wherein they have the volume that attaches the service account token. So yeah, this is just an example. Like they're trying to give you an example of how using any programming language of your choice, you can add an admission controller, like a mutating admission controller, to your cluster. So this is by a programming language, like any programming language. And the second way you can do it is by using controller runtime. This is something new I did not know before reading this chapter. This controller runtime is a upstream project which provides you with few functions which are basically which basically help you to write. So this is a lot of code, right? This is a lot of logic and code. And they also say that note that the actual implementation for this admission webhook includes some additional functionality that also adds to the patch set. So this is just like a boilerplate code example that they have given, but this might require more code to actually work. And then to make it more simpler, I think the communities come up with this controller runtime, which is open source and which provides some functions which make it easy to write admission controllers. There is a small note about Cube Builder, which also uses the same controller runtime inside its core to write operators. The controllers will be walking through. Yeah, so this is an example. So what they're trying to do is they have this use case wherein they want to add an IP address. They want to call outside an external system, which is in info blocks, and they have a small amount of boiler. They want to provide a small amount of boilerplate and extend the functionality. So this is like a perfect use case for a for a admission controller. And so yeah, so this one, like the container the controller runtime, it provides some functionality um, like the handle method. So they have this handle method, and just give me 1 second. Usually there's not a lot of sun at this time, but yeah, it's kind of getting in my eye. So yeah, we were talking about this controller runtime methods. So they have these methods that can help you write the admission controllers, like handle, and there are different methods you can see. The request method, the handle method, and yeah, and there is one more method that they talk about, which is the um, yeah, there's this admission.allowed, admission.denied. There's one method which was yeah, patch response from raw. So this method would directly give you a JSON response for the kind of for the logic that you have written. So basically it provides few methods, uh, and that make it easy for you to write um, the admission controllers. Are there any questions for this one?
No, I don't have.
Okay. So the last part, so yeah, this small note is again says the same thing. Like it says that if we are manipulating external state as part of an admission controller, we need to of ch- uh, be aware of and check for the request or try run condition. If this is set, the user is only executing a try run, no op request, and we should ensure that our controller does not mutate external state in this case. So this is one kind of alarm that we need to follow. And the last part of this chapter is centralized policy system, which is, I think, the I don't know if I should say this or not, but it is kind of the industry standard right now, like that most of the people use. And and the advantage of using this is that is that programming knowledge is not required to create admission controllers, and policy and rules are stored in a single location inside your cluster for viewing, editing, and auditing. And the only things that you need to know for actually applying this is basically there is a query language. In this case, it is like in the case of gatekeeper, it is called as rego. So you need to know that query language, and a controller that sits in the cluster serving as an admission controller. So these are two things that it is comprised of, right? And so what are we talking about? We're talking about OPA, which is Open Policy Agent. And Open Policy Agent is basically a project which is a policy engine basically, and it is irrespective of Kubernetes. It works for like different. You can make it work for say your Terraform or any other application, but to make it is just a policy agent which kind of tries to enforce policies. And then gatekeeper is a tool that is a link between Kubernetes and the OPA. Like it makes OPA available to the Kubernetes community, uh, to the Kubernetes cluster. So for this chapter we are going to see how gatekeeper helps us create the uh, the admission controllers and apply the policy engine to our Kubernetes cluster. And Nipendra also mentioned about Kyverno, which is also a tool which is gaining traction right now, like Gatekeeper. So
I believe this book is a bit few year old, right? So I think Kyverno, I think, has got a lot of traction after that, right? And Kyverno being Kubernetes native, it is kind of mostly as people are using Kyverno, and if they have a mixed workload, then OPA. That's what I have seen, at least whatever I know. Yeah.
yeah, so from my recent understanding, Kyverno also does a lot of like it does do the policy engine stuff, but it also does like a lot of SBOM authentication certificate. Like it's a lot more into supply chain security as well. Like apart from being a policy agent, like it has additional features.
It would do. So I'm not. I tried one demo very long back, but it works, right? So I think maybe we just open the Kyverno. I'm just opening the Kyverno website right now. So I believe it is policy only. It does with the help of other tools, right? So SBOM, in the SBOM entire flow, Kyverno would be part of it, I believe. So it would not do the entire SBOM itself. It would basically uh, become part of somewhere in the entire cycle of that SBOM part or supply chain thing.
Got it.
I had a question around Keyword, no, specifically not around these mutating webhooks or whatnot. So we were trying. So we have Kivano for one of our customers, and one of the policies that we were trying to set was that every namespace should have a resource quota defined, right? Because you can set quotas for namespaces as well, just like you can do for pods, right? Resources
Yeah.
elements, you can have it for namespaces. So now, if I want to enforce that every namespace should have a resource quota defined, I couldn't really get it working. And the problem there was a catch 22 because to create a resource quota, there should be a namespace. And if I apply a policy to the namespace that a resource quota should exist, it just doesn't work, right? Because you can't create a quota without a namespace. And if you block creation of namespace, the quota will not be created.
Oh, is it okay?
Yeah, probably I'll share some steps to reproduce, and maybe in the next session, maybe we can just see if uh, this can be worked.
Yeah, I'm just yeah. We can just see resource quota. Okay, go ahead, Rahul. Go ahead. Meanwhile, we'll just
Yeah.
proceed.
Also, like the thing that I mentioned about SBOM and stuff like that. That I pasted a link in the documentation. Uh, doc security, and they have, like as you mentioned, like they have different integrations with SBOM, with Into2, and other
Correct, correct. They'll have the
security.
integration.
Correct, correct. All right. So talking about Gatekeeper now. So Gatekeeper is deployed to cluster as an admission controller that allows users to write rules in Rego to make admission policy decisions about Kubernetes resources being applied to the cluster. And so yeah, that's basically what Gatekeeper is. Um,
So one thing I recently heard about the development, right? The policies what we are putting right now with Kyverno, they would be, I believe, inbuilt into Kubernetes code itself, right? So Kubernetes would have a feature of that. Anybody has any insight on that?
No, not really, but that would be great for Kiverno guys. No?
No, so they need to figure out something else, right? If
Oh, you mean an alternate implementation from Kubernetes? I thought they are kind
yeah,
of
yeah. So
pulling in
basically,
Kiverno as
say
part of default distribution.
no, 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 no.
Oh,
Policy enforcement. I'm just trying to get that in Kubernetes. Yeah. Because I read somewhere that it is coming as a part of it. I'll let you find that out because that's it. Kind of mentioned that after that, if this feature comes up, Keywords has to kind of do something more than what it is doing, kind of a thing. But I may be wrong. Yeah.
yeah. Yeah, true. I mean, I remember reading something on Twitter. I can't find that as well right now. That Kyverno is also trying to move out of Kubernetes, something similar on the lines of OPA, and probably this could be the reason that you're saying, right? Because now if uh, Kubernetes does it by default, uh, they have to find something else.
Yeah, there should be something else for sure. Yeah. So yeah, I think that's what I know right now. That's there. And if anybody has anything, yeah, I think there's a policy. Yeah, so I'll just share this link, and we can maybe just read through a bit. And if this link makes any sense, I'm not too sure, but let's just see. No, I don't think that's the one.
No, this is not the one.
Not the one. It's not
This
the
has
one.
always been there, right?
Yeah, it's already been there. Correct. Yeah.
Yeah.
So it may be somewhere in the SIG or somewhere it is there where I read it.
Hmm.
But something else coming that there going to be something inbuilt as a part of your pod configuration or deployment, whatever. There will be something which you can apply or put it at the communities level itself.
Interesting.
What do you
nice.
guys? What other people have seen? What kind of use cases? I mean, have you seen OPA or Kyverno? What you have seen? How people are using for policy enforcements? Anyone has any idea on that?
Yeah. Kyverno is helpful when you are doing migration in a multi-tenant environment. For example, many teams are using without your knowledge, and you are using a deprecated version or something.
Mm-hmm.
So you want to discourage people to start creating them, and you don't have to go and announce them. Even if you announce, some people will start creating it. So the policy will help you to reject those requests. Like for
Correct.
example,
Hmm.
auto scaling V1 beta 1 to stable, for example, or something like that.
Correct. Even for ingress also maybe something like that. Old ingress
Yeah,
type
yeah,
those things. Yeah.
yeah.
Yeah. Very good point. Yes. Any other inputs, guys? Okay. We good.
Okay, let's continue. So yeah, so now the thing is, like, there's Gatekeeper and there is our Kubernetes cluster, right? So now the cluster needs to know, like Gatekeeper needs to know what are the things which are there in the cluster, and what it needs to what it needs to access in terms of applying such policies for the requests that are coming in. So there needs to be something called as a config. right? Like the gatekeeper config, and how it looks is what its job is basically to sync the cluster configuration with what gatekeeper knows. So there's something called as gatekeeper's cache that it maintains, so that it does not have to query the API, the Kubernetes API again and again, right? So this is how the config looks. Um, and the important part is here, like sync. And what do you want to sync? It wants to sync version 1 kind ingress, and from different groups. So first was extensions group, then was networking group, and yeah, this is like the default one, and it is doing the kind as namespace. So this is the information that would be synced and saved in the gatekeeper's cache. And then there is a note about this cache, is that basically, because of keeping a cache, the gatekeeper would not make a request to the API, and it could use a stale data from the cache, and not use the actual one, like not doing the query. So to mitigate this, there is an audit capacity uh, that can be used to actually do query, and basically check the drift between the Kubernetes configuration and what the cache has. So this is how the config looks. And once you have the config, then you need to define something called as a constraint template. Now, this template you need to define, and the name of this template is the kind of this template is then used to instantiate. So let's wait for that. We'll talk about that in a minute. But two important things in this constraint template are these properties. So these properties are basically the input that you're going to get from the request, and targets is the condition that you want to apply on the request. So the input here is an annotation, and that annotation is of the type string, right? This is the input that you're going to get, and the target is the condition that you need to write in the Rego language. So in this case, what they're doing is they are checking if uh, the namespace that we have, um, yeah, it is checking the rules section, and it is checking for the host of the namespace, I guess. That is the condition over here. So yeah, you can write the condition here in the Rego language, and if it errors out, it will say something like it will print an error, and it will match things, and it will print an error. If it did, so this is basically the condition, and this is the input, right? And then the next thing you need to do is that you need to create a kind of limit namespace ingress. So this is the one which we have used in the constraint template, uh, and then we can create a resource of its own type, of its own kind. And here we mention like which API groups we want this to be applied, and the kind is ingress, and the parameter is the annotation, and the annotation should be called allow ingress pattern, right? So this is the kind that you can create, and once this is created, now you can use it in your namespace. So say for example, this is a namespace, and then you're using the allowed ingress pattern, which is the annotation that you declared in this kind. And now allowed ingress pattern, you can set regex here, which is like any word dot my namespace dot com. So now, and the name is the name should be ingress test, which is again from the previous one. And now in the in your actual manifest that you are going to do, deploy, there you will check this particular annotation, which is called allow ingress pattern. And uh, in the rules that you have set, you are checking the host. So here the host is like foo.othernamespace.com, which does not match with this, right? It is my namespace.com. So this will kind of fail. And the second one over here, it is foo.mynamespace.com. So this will pass. So just to recap, you have a constraint template in which you define the kind, and then you define the parameters that you're going to take. In our case, it's an annotation in the string format, and then you define what constraint you want to apply, which in this case is it is checking the host or host of the instantiated ingress, and then in the next step you create a kind uh, from the constraint template, and you define for what you want to apply it, and the annotation. You need to define the key for the annotation, and which you can use in your actual namespace, like the resource that you want, and you can define the pattern over here. And once the pattern is defined, you can use that pattern in the same namespace, and it'll check for the host name. So this is, and if it does not match, it will kind of print this kind of an error. So this is, I think, all about the gatekeeper. If you have any questions, comments.
I always found Gatekeeper a bit too confusing. I mean, not I mean, it's not. I think I not given enough time to it. But yeah, so and easier one is there for keeper. No, I just lean towards that always, rather than try to do that, because maybe I not found the use case where I have Kubernetes and other things together. Like that's why maybe.
Yeah, I think it's a lot to
Yeah.
configure.
Yeah. Okay. I think that's just kind of finishes the chapter, right?
Yeah, this is just like kind of an overview, like why gatekeeper, like the strengths of gatekeeper, and only one drawback is that it is unable to mutate requests, right? It is only able to validate requests, gatekeeper,
Is it?
and
Okay.
yeah, it is what the book says.
Okay.
And
Hmm.
there are entire books written on this topic itself, I guess. And this book is also pretty old, so I'm not sure if this still is a constraint.
Yeah, that's why I don't expect this to be a constraint, but I'm not too sure.
Yeah, same.
Okay,
And then
great.
it says one last consideration when utilizing gatekeeper is that the scope of requests captured by this tool is likely to be very broad. So that should be the end of this chapter.
Okay, thank you, Rahul, for covering this chapter, leading the effort on this.
I think it's a
Um,
record, right, Nipendra? I mean, finishing a chapter in one sitting,
yeah,
it's a
yeah,
new
correct.
record.
It's a new record, yes. Of course, this chapter is a bit small as well. Yeah, so that is also
Okay.
one case.
Mhm.
But yeah, I think it's good that we could finish one chapter
Nice,
in one
nice.
go. So
Thanks.
that is,
Thanks, Rahul.
yeah. Um,
Is it an indication that I went too fast or I was not able to explain?
no, no, no. It's just that I think the kind of I
No,
think
it just means that everybody here is very smart, and they kind of understand everything very
correct.
easily. That's all it means, buddy. Nothing about you. It's about
Nothing
us.
about right. So yeah, that's great that we could finish this one in one sitting. So for the next session, we have observability, and we have Walid. I think he volunteered last time, but I'm not too sure if he would be able to take it. He's not here today. Um,
I can take it up.
so
Not an
okay,
issue.
that's good then. Okay, then I think we are all set for the next one. And after the observability, what's the next chapter? Maybe if anybody want to pick
It's
up, but
called
right now,
identity.
identity. So mostly the is it RBAC part? I don't know what it is. What would be in it?
I think it's about workload identity, service accounts, something around that mostly.
Correct, correct.
IRSA. Uh,
Okay, so I think observability would be I think should be a would have a good content for at least two sessions, I believe, right?
mhm,
So it is close to 40 pages, I believe. Less than that actually. So maybe I don't know whether it can be done one go, because there is another book of observability which is there, which kind of
mhm,
get into much more detail.
mhm.
But I think we can cover whatever here in the next session, and then maybe we'll cover the observability book, which I would highly recommend that we'll take it some other time. Or that book from
Sure.
Honeycomb is really good. So, but
Yeah,
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 as a
yeah.
part of this book, we should just finish this. So I
Mhm,
think yeah, that's there.
mhm.
Um, Anybody want to volunteer right now for chapter 10, so that you have some time? Um, yeah. Otherwise, we can always discuss next time. Okay, no volunteer yet. Fine. Hopefully, we'll find next time. Okay, then I think we are good for today's. I think it's already 9 and 5 minutes past 9, or IST 5 minutes than what we usually close. Okay. Anything? Any other points, guys? Anything else?
No.
No. Okay, then. See you guys next time, next Thursday.
Yeah.
Yeah.
Thanks. Thanks,
Bye
Thanks.
guys.
bye.
Bye
Bye.
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 Thank you, Rahul.
Thank
Bye.
you all. Thank